Hello.
Greetings of the day, everyone present here. A warm welcome to Dr. Ghazala. We welcome you all to the session 2 of our AI-driven internship program. I would like to say our previous day recordings has been updated in our classroom. Kindly check with that. If you face any issues, you can post it in our Telegram discussion forum. With the same into from session 1, I'd like to hand over the session to Dr. Ghazala for session 2.
Hello. Good evening, everyone. Am I
Yes,
audible?
yes, you're audible.
Okay.
Please take up the session.
Okay. So everyone has joined the session?
Yes, we can start. It's already done.
Okay. Okay. Sure. Mm. Yeah. Let me share my screen first.
Kind request to participants, kindly unmute yourself only if you have any questions. Till then, please keep your mic in mute.
Is the PPT visible?
Yes, it's visible.
Okay. So good evening, everyone. Uh, as we have already discussed, application of machine learning in gene expression analysis and some basic concepts about machine learning we already discussed, like what are the algorithms there and like how it actually works. But today we are going one step deeper into the functioning of how machine actually learns and what are the different steps that we are going to integrate in our expression based data analysis. So, like, if any, before starting the session, I would like to tell you that if there is any query from anyone in between the session, you can just drop down in the this chat box. I will check it as we are going through the session, or later also we can discuss after this session. Like at the end, we will have some 10 to 15 minutes, then we can discuss the queries. Okay. So we already have discussed like what is difference between machine learning and artificial intelligence. As we like I explained you that machine learning is basically the subset of artificial intelligence, where artificial intelligence is a bigger picture in which the machine learning is a small part, where we are trying to just teach the machine, or machine will learn from our data.
Dr. Gasala, it seems your mic got muted. Can you hear
Okay.
me? Yes, please.
Hello.
Now
Yeah.
you're audible.
Okay.
Please.
Okay. So, mm, okay. Like okay, let me start from beginning. So, like as we have already discussed, what is machine learning and what is difference between machine learning and artificial intelligence? Because as we discussed with the like graph that I showed in the last class, that artificial intelligence is a bigger spectrum, and then in that the machine learning is just a subset. We are trying to teach the machine to understand the pattern from our data, whatever data we are giving it, and then once it is learning from the data, it will try to learn from it and then implement that learning in the new data what we are providing to it. So it whenever we do traditional programming, there we need to provide the program also with the input. so that we can get the results. But in machine learning, we are just providing the input and the output. The machine itself will learn the pattern and store it in form of models. Okay. So here we can see that, like, okay, so in traditional programming, as we discussed, like data and program will be provided to the computer, and then it will provide us the output. Like if we want the sum of two digits, then we will give two different digits like 1 plus 1. And then program we will give that 1 with addition function and then 1. So it will provide us result as 2. But here in machine learning, we are just providing data as 1 and 1, and the output we are providing 2. Now the program or the computer program itself will learn that how from two ones, how the output, what program it will make so that the output will become 2. And accordingly, it will make a model based on that. So this is a famous saying by Kevin Murphy that goal of machine learning is to develop methods that can automatically detect patterns in data, where we don't have to make the patterns by ourselves or design the patterns or the program by ourselves. It will automatically learn and understand the pattern, and then use the uncovered patterns to predict future data, or from the new input data, it will learn that what output will be produced. Okay, so types of machine learning techniques, we need to understand that what are different types. So this also we have briefly already discussed, but now we are expanding more in each category that we have already discussed in brief. Here, when we categorize machine learning broadly in supervised, unsupervised, and reinforcement learning, then further supervised learning will be divided into regression and classification type of learning. Why two type of category is there? Because depending on the input data, when we have the numerical data or the continuous data in form of numbers like 2.1, 5.10, and other numbers like even greater numbers. So when we have the number format data, numerical data, we perform regression. And when we have value categorical data, for example, true false, 0 1, or malignant non-malignant, healthy sample or the disease samples or the tumor samples. So when we have two or more categories, then we try to use classification algorithms only. So there are some algorithms that work for both type of data, like we see here in ensemble methods. We can see decision tree, random forest, and like extreme gradient boosting, and then categorical boosting is there. So there are algorithms that work for both types of data, but sometimes we use sometimes our data is less, and sometimes it is more. So based on the type of input data, we try to select that which algorithm will work better on our data, and then accordingly we will select that what is the final objective of our analysis. Again, in unsupervised learning, where our data has no label, like as you might have remembered that I mentioned in the last class, that in unsupervised learning, we don't have the labels on our data. So when we are not having labels on data, we perform clustering or dimensionality reduction, because if there is a high dimensional data, so we try to reduce the dimensions so that we can see whole data, like 25,000 genes if we have from our data, then we try to view it in one small image or the figure that we are generating from PCA, that dimensionality reduction figures, so that we can see like how our samples are behaving, like how they are categorizing, or even in clustering, we see like how different samples are making cluster. Either the healthy samples and the disease samples are in same clusters or different clusters. So accordingly, based on our objective, we try to select that which algorithm we are going to take to design our model based on the data we have. Again, in reinforcement learning, this is reinforcement learning, as you might have remembered already, that here we first provide the data to the machine. It will try to learn and implement that learning on the new data that we are providing. But if the results are wrong, it will give some score. If it is right, it will give positive score. If it is wrong, it will give negative score, like whatever the user or has decided to give the score. And based on that, it will try to relearn from that scores, because if negative score, then it will see that score is negative. It means it has not predicted the values right. So it will try to relearn, and when next time we will provide the same new data or other new data, it will try to improve its learning in the next time, or the every time we are providing the data, it will try to learn new things from it and then implement it. So, like we have discussed that broadly we can categorize our machine learning algorithms where supervised, unsupervised, based on the types of data. Like labeled data will be under supervised category, unlabeled data will be unsupervised, and semi-supervised will be like some of the data will be labeled and some of data will not be labeled. And reinforcement learning, where the learning will happen in cycle, like one learning is performed, then finally the model will be evaluated and relearning will be performed if the model is not performing well. So model will learn from its mistakes. Again, when we look deeper into the supervised learning, like, okay, so I think, okay. Please don't use your cursor, like
Yes,
all
Miss
the,
Sade, please don't write on the screen. It's disturbing others as well. Kindly take your notes in your paper or pen, whatever you have. Please don't write it on the screen. Yes, please
yes,
continue.
please. Okay. So, okay, I need to move this as well. Yeah. So when we look into supervised learning again, so we now totally understand that how it works and on what type of data it works. Like we need to have a labeled data so that where the categories are clearly defined, that whether these samples are from healthy or the treated samples or the disease samples. And then again, once the data is labeled, then it will try to predict the outcome from the new data, which is unforeseen data. The program has not ever seen that type of data. For example, if we are training a data for breast cancer, then if our model is performing good and accuracy is too good so that we can use the model as a final model, then we can try to give the same model input for the lung cancer or any other type of disease, so that we can see that either our model is working for all type of diseases or all type of gene expression, or it is showing is same type of results for specific data only, or the data that we are providing. So better, so the our model will be said good, performing very good, or it can be generalized for all type of diseases when it is giving good accuracy for all type of data. Okay, so the one of the major challenges, the data need to be labeled in supervised learning, because most of the time we are using supervised learning only when we are doing gene expression analysis or the classification of two types of samples, where we have the healthy samples or the treated samples. So that is the that comes under the supervised learning most of the times. But the challenge is we need the data to be labeled. Like there should not be any gene name missing. There should not be any sample label missing. For example, if one of the healthy sample label is missing and mistakenly we are making the label it as disease sample, or say the tumor samples or the cancer sample, then it will give us wrong result, because originally it was a healthy sample, but due to the missing value, it we have labeled it wrong and the results is wrong. And never we try to remove the sample from the data, because sometimes when we are working with the open source data, we have the limitation of data. Like there will be very less number of samples. Sometimes we have 30 samples, sometimes we have 60 samples only. Like we are not usually working with thousands of samples when we are doing this type of analysis. So we do this type of like bigger projects had like 1,000 samples, sometimes, often, like not usually but often, but like usually we work with less than 100 samples only in each category. So we try to not remove the samples at all. Like we try to do the annotation, try to search for the label for each sample very clearly, and it should not be wrong. Like from every possible source we can try to label the data so that our results will be more precise and more better, and not give us misleading results. So this is one of the challenge, that data should be labeled in any way, otherwise we will not be able to perform supervised learning. And even the data is not labeled properly and we are trying to perform supervised learning, or with the using supervised learning algorithms, then it will result in misleading results. So sometimes it is it is very costly, or sometimes it take also more time for that. Because labeling is not a like very easy task. We need to search for databases, like very accurate and authentic genuine sources from where we can properly label the data. So this is one of the challenge, but it works very good when we have the categorical data. For example, like two categories, healthy diseased or the treated disease samples kind of data, or benign malignant data if we have. So supervised learning work very well with that type of data, but we need to have the label data. So in that we need to be concerned about the data first, that our data should be complete and completely labeled also, so that we can perform the learning, this type of learning algorithms we can apply on that. Next is unsupervised learning, where we are not having the labels on our data. So the machine itself will try to identify pattern by itself and categorize the data into two different categories, or even if we have three different type of samples, then it will try to categorize it into three different clusters, or make the groups of these three different clusters, so that it can be differentiated clearly from one to other, that okay, this cluster is from healthy samples and this is from the disease samples. Okay, so sometimes like when we are performing unsupervised learning, there we are not having labels. So this is one of the disadvantage in unsupervised learning, because we are not having labels. So we need to take one more extra step, or follow one more extra step after making the cluster, to identify that which cluster is for which group. And we need to further identify or further go for like a database search or other steps. But in supervised learning, we are at the first step itself, we are trying to perform that step with the learning process, so that we do not have to do extra step after clustering of the data or the grouping of the data. So in semi-supervised, again, we know that this is some of the data is like labeled, some of the data is not labeled. Like, so some of the examples are where students is under the supervision of teacher at both home and school. So sometimes like teacher has the name of the students. Sometimes they are not like marking the like attendance of the students. So sometimes they are having the complete data, or sometimes they have incomplete data. So this type of learning is does not like usually found like result in very accurate results. But when we have incomplete data and we have no other way, like the data information metadata is not available for our data, we are not able to label even, and the like pattern in the data is also not clearly defined, then we have to use these type of semi-supervised type of learning methods, and those algorithms we need to use to make the models, so that at least we can get some results like that is that may have some insights for further study. And again, in reinforcement learning, as I explained, that it try to learn from its own mistakes, like in the first learning phase, when it is giving some results and the rewards are given. So based on the decision, the rewards are given, and the feedback will be provided for the prediction that learning the model has provided. So based on the rewards, if it is a negative reward or the positive reward, it will try to relearn from the pattern that it has obtained or learned from it for first phase, and try to improve its performance from its own experience when there is no. So next time, when in the first phase, when it is already learning, so next time we are not again providing it a new data that, okay, you have not learned first time, so now you have new data and learn again. It will try to learn by itself from its rewards that it is providing. So rewards are in form of weight. Is like sometimes it is +1, -1, sometimes it is 0 or 1. So whatever we are providing to the program or the machine, it will try to evaluate its performance based on those rewards. So some of the basic keywords that we need to understand in while performing machine learning is, first is the features. Like once we have the data, we need to understand what are the different features in our data, so that accordingly we can see that whether this feature is relevant to us or not relevant to us. So this is for the weather estimation project, when it is features is provided in terms of temperature, humidity, cloud coverage, wind direction. So these are different features in this data. Like based on the temperature, we can say that what is the weather, it is sunny or it is humid, or then based on the humidity number, the score is given based on the scale that is generally given for the humidity scale, and then what is the cloud coverage. So these are the types of features that is going to decide that what will be the weather today and what will be the weather day after today. So this include in features. Next is uh, okay. So the features will be used in training your data, because from your features only the data will learn that which feature is important, which is, for example, here in the data we can see the temperature is given 74 and then 82. So your program will learn from like what is the relation between temperature and humidity and how they are correlated, so that when the temperature is 74 and humidity is 20, when at that time the weather is sunny, and at when temperature is 82, humidity is 42. So what is the correlation between each features? The program will try to learn and compare the features from each other, and then it will establish some relation between each features, and then it will try to learn from this and make a program so that it will give a label or the output as final output. So here we can see like the label. So label is basically what we are trying to get. For example, here we are seeing that the color is given for the sports car, that if the color is red and it is type this is the car categories where the type is the sports and origin is domestic. So the label is given that if it is stolen or not. So based on the color, based on the type and origin, so these are again different type of data where the features are in form of color, type and origin, and the label is that categorical label, that yes, either the stolen category, stolen feature, it is yes or no. So based on the features, it will try to label your data. For example, if you are providing these 6 rows of information to your machine, so it will try to learn that the date when the red color is there and sports type is there, origin is domestic, then those type of cars are stolen. And when the color is yellow, sports type is sports, and origin is domestic, that car is not stolen. So based on this, again, it will try to relate the features from each other and make a correlation between them, then make a program so that next time when you are providing some information, for example, you are providing the color is yellow and type is SUV, because in this data, this information, this type of data is not there, where the color is yellow and type is SUV, like the last row we can see here. So, and the origin is domestic. Okay, so when you are providing that type of row to your data, then it will make it has already been learned from your data that you are providing in the training section. So it will try to predict the label based on your input from whatever it has already learned. So these are the labels which are the final result that you are trying to achieve from your machine learning model, that either it is predicting the right answer, or it is predicting the wrong answer. So based on the prediction level, it will our accuracy of the model will be calculated. So the model, what is actually the model? When we have already learned that labels are there in the data and there are features in the data. So once we have the label and the features, now we need to make a model, because data we already have. Within that data, we have the label. Within the data, we have some features. And based on these label and features, the model will be made, which will show, or which itself will be calculate, or it is calculated the relationship between these features and labels, as we have already seen that how the model will try to make a feature relationship between the features and each label which is given, that how it can predict the label correctly based on different features given. It will generate predictions using the patterns that is extracted from the input data, like data with the new data we are providing. Then it has already learned that what is the pattern that the data is following, and it will predict the answer from your new data as well, and also from the data that you are already providing, because it is learning on the same data. So what is the model where we are getting it? The model we will get after when we are this is making a mathematical equation, or like based on the relationship between the features. It will make a equation. That equation will be saved, and then it will be saved in terms of model. So when the relationship is already made, and then it is decided that okay, it is this relationship is like differentiating or categorizing or two type of samples in two different categories properly. The accuracy is good. Accuracy is 90%, accuracy is 80%, 88%. Then we save that program into format, and then RDS format, and then that we will call it or store it in any variable, like in R, if we are saving it in form of variable. So the saved variable that is correctly categorizing our samples, that is called the model, which is the final result for our machine learning training purpose, or the result of the training step in our machine learning. So basically, when we are providing the data to the machine, and then machine learning algorithm will be like calculated from by the machine using our data and learning the pattern. It will give the machine learning model, because it has learned from our data. Okay, so data we have provided, so it will learn the patterns only from our data, not any other data. For example, if you are giving data for the disease type of data, or the for cancer data if you are giving, and next day you are trying to use the same machine learning model for example fruit categorization. For example, okay, you are providing some images of the fruits, like apple, oranges, and you are asking the model to differentiate between two fruits. So it will not able to perform like properly, and it will give like accuracy of 0.1 or 0.2 or 1% or 2% or maybe 16 15%. So that is not good accuracy, right? Because it has not learned on that type of data. So machine learning models are specific to your data. like whatever data you are providing. So and what are good machine learning models are those models, for example, if you are working with gene expression data, so and that also RNA-seq data, which is transcriptome data, if you are working with that, then if you are providing RNA-seq data even from lung cancer, even if you are providing for another cancer, then it should perform better. Like not like directly, if it is giving 80% accuracy on your data, then it should at least give 70% or 75% accuracy on the same similar type of expression data, like from any other disease. But so that type of model are called as good model, like generalized model that can work on other type of disease also. But if your model is specific to only your data, and when you are providing, even if you are performing analysis for lung cancer and other type of data set you are selecting and giving the other type of data to the same model, it is giving like even 50% accuracy. So that is not a good model, because it is specific to only your data, and it is not able to even differentiate between two types of categories of the samples, even from similar data which is provided from other data set but same type of disease. So that will not be called as generalized model. So that's what you have to learn, that you need to improve your accuracy and keep optimizing your model to improve its accuracy, and also to avoid overfitting and underfitting that we will discuss later. So the steps that we need to follow while performing machine learning analysis will be collecting data. First, you need to have first some objective that what you are going to perform. Then collect the data, that type of data that you are going to perform the analysis. Prepare the data, where you will be analyzing your data, whether the data has all the labels, whether it has some labels and some are unlabeled data. And then you have to see if the missing values are there. For some genes there is no expression given, so for that you will be like looking out that how to fix that missing value. So that also we will see how to fix those things. And then once you have the data prepared already, like cleaned and prepared, then you will train the model based on your data. And after model preparation, you will evaluate the model, that if whether your model that is trained on your data that you have provided from the first step, whether this is working on the new type of data or not, or even half part of your data if you are providing in the training section, then half data that you have not yet provided to your machine. Now in the evaluation step, you will provide that new data from half part of your data itself, which is following same pattern that you have already provided. Based on the new data that you are providing, is your model also giving same type of accuracy? For example, training model is giving 80% accuracy, then at your evaluation step also the model should give 80% or even 82 or even 78%, at least nearby accuracy it should give. And then based on the performance of the model, you can go and deploy the model, so that after deploying you can use for any like same type of data, like the gene expression data, whatever you are using. So that type of data, you can use that model again and again. You just give the input of the data. You don't need to train the model again and again. You just give input to data and predict your answer, where the labels are not given even for that. So it will predict the label for your data. Okay, so if when we like explain the steps, we see that after data preparation, we need to choose first the ML model. So why to first choose the model, that what type of algorithm? So basically here choosing ML model is basically choosing the algorithm that you are going to use to make a model, because model is making based on your data. Okay, so the here choosing model means you are choosing the algorithm, the machine learning algorithm from which your data, your this algorithm will learn from your data, the pattern it will learn. So choosing model is one of the like very, like all the steps are very important, but choosing model is very critical step, where if you are not choosing a right model, then you may lead to incorrect or not precise results. So or maybe you will not achieve good accuracy. So for that we need to choose the model very wisely. We need to consider a few steps that need to be considered while to make a good model. And then after choosing that which algorithm you are going to train your model, then we need to train the model by dividing your data into two parts, like training part and the testing part that we have saw in the last class also. And then based on the after the training is done, we will evaluate the model. If your model is not performing well on the new data, that after training you are providing a new data to your model and your model is not performing well, then you will go into the parameter tuning step, where you will try to optimize your model so that it will perform good. For example, when you are making a random forest, like using random forest algorithm here, like choosing ML model here for random forest to make the model. So if it is not performing well on your new data, so what you will do in parameter tuning is you will try to adjust the number of edges, number of leaf nodes in your random forest. Or even in random forest, the random forest is basically collection of decision trees. So you will try to optimize, or when you train the model, it will run with the like default values, like number of trees in your random forest will be default value. But when you try to parameter tuning your, like optimize your model, you will give more number of trees. For example, if the default tree is 5, so you will give 15 as a parameter tuning, and you will again try to train the model based on that number of forests, like 15 forest in your random for 15 trees in your 15 decision trees in your random forest. Based on that parameter tuning, if your model is again going to be evaluated, and then if it is working, performing well, if it is giving good accuracy as it was giving in the training phase, if it is giving good accuracy, then it will leads to make prediction, and the prediction will be evaluated that whether the prediction is right or not. And if prediction is right, then it will go to the deployment phase, where the model will be deployed and will be said that okay, this model is generalized for gene expression based on specific type, specific data, like gene expression data that you are using. So first is the data collection phase. So as we know, like you might already know or have worked with machine learning algorithms. Like we collect data from different sources, like we have UCI, and then we have other databases like NCPI for biological data. And and then different data formats are also there. So based on that, we need to first collect the data, like based on the objective that you have, what you want to do. You want to do imaging data classification, like MRI, CT scan data. You want to do gene expression based data analysis. So for that, you will collect data from NCBI and AMBL, other databases that are there. So based on the objective, you will first perform data collection. And the data collection methods include like primary sources, it can be obtained, or from the secondary sources. So primary sources will be directly from the labs, if we are talking about the biological data or the molecular data. And if you are talking about the secondary data, then that will be the open sources databases that are there, like NCBI, AMBEL, or even the publications that are available. From that also we can see that what data set they are using and what data they are providing. Sometimes the papers has the link for the data that they have used, so you can go through that, and you can collect the data from there. Then second step is the data preparation. In this step, you need to analyze your data, that what is the data format, either it is a structured format or not a structured format, like columns and rows are there, either they are labeled or not. Then what is the size of data, it is too many columns are there, then like you can not properly work. Like sometimes we say that data preparation can be done in Excel also, like because we have the data, but there are like sometimes when we are using gene expression data, so there are 22,000 genes, right? So 22,000 columns we cannot see at once in the Excel file at the same interface, right? So and we cannot able to like see the where are the labels there, or where the labels are missing or not missing. So for that we need the programming. So and those who are concerned about the knowing programming and learning programming for machine learning, so there are web based applications also, like machine learning platforms, where you can provide your data, and it will show, like it will process. You don't need to write the code, you just click on the steps that is given. You need to perform data preparation, you will just give the input that I want to do the data preparation, and it will automatically at the back end, it will perform the data preparation and give you a clean data. So you may not need to do the programming. But I would suggest, like personally, with the personal experience, that you should start learning. If you don't know, or maybe if you know just the basics, you should start learning some of the programming. And if you are totally a beginner, like okay, so okay, can you please tell me, please write in chat box, how many of you already know programming, and which programming language do you already know? And if you don't know any programming language, can you also please write none, so that I can see, so accordingly I can explain things, because those who know programming already, it is easy to explain to them. Okay. Okay, I can see like many of you know Python, and few of you know R, and few, like I think 50% of you don't know any programming language. So no need to worry. Like even if you don't know, you can start from this course also. I will explain you like each step that we are going to do in during our session. I will explain you how we are doing, and then you can start. Like learning is not difficult, but you need to know basics. So I will also share you one study material where you can start from basics. So for R, basically, because those who already know R, they need not to worry that they need to have learned Python or not, because those who know R, they can continue with R. It is working equally well as Python. And those who know Python, that is also very well for you, because Python also has like too many applications for both bioinformatics and also pure machine learning also. So and those who don't know, they also need not to worry, because we are going to do this all the analysis, like whole gene expression analysis with our programming, and some of it we will do with Python also. So you will see like how we are doing it, and step by step I will explain each module, each every keyword, every vocabulary, every variable that we are using there, so that you will understand. And maybe you can also ask there your queries. If you can also post your queries in the discussion forum, so that I will be there for you to help you and guide you accordingly. You can learn. And yeah, don't worry about that. I am talking most of the times about programming, right? So you don't need to worry, I will be there to explain you, and it will be very easy for you to learn along the class that I'm going to share. And when we will discuss, when we are going to do the practical session, it will be more interesting for you. So trust me, let's just complete the theory section, so that I am also like looking forward for the practical section, because that is more interesting part. So, but before practical, we need to know the vocabularies or whatever the keywords that we are going to use, because in the class, if I am going to use, say, the data preparation step we are going to do, so you need to understand that in data preparation, what are the things we are going to check. We will check for the formats. We will check for the organization of the data, whether it is a tabular format, whether it is given in the text format, or sometimes data is in XML format. So we need to like convert the data in tabular format to the Excel format or CSV format. So all these things we need to check in the data before proceeding for the model preparation or model training. So this is the data preparation step. Furthermore, how the preparation will be done when we are going to download the data. So I will download we will do steps one by one, and from the very first. So you will see how to download the data, from where to download the data, and like how data exactly looks, and then how we are going to prepare the data. So as the data comes, we see like how the, because every data is different. Sometimes data is totally in different format. So we need to see, like we need to require to convert the format or not, and what what is the size of the data. Accordingly, we need to sometime remove some of the columns that are not relevant, some, because sometimes when we are doing gene expression data analysis, there is also data, the metadata given for the age, right? So in gene expression, we have the expression like gene expression like 1.4, 3.6 or something, or like in that range, like 1 to 10 range, if we have the gene expressions for all the gene that we have. And we have the ages from 31 age of the patient, or the 61, 65, 68. So the data is not relevant, right? Gene expression is following totally different scale, and the age data is following totally different scale. So sometimes we also remove the columns from our data, so that all the things comes under data preparation, where we need to like very calmly and like focus, with full focus, we need to observe the data, so that our data should be very well structured, very much clean, so that there will be no probability of error in our data. Because sometimes we are giving different scale of data in our same data to model, to make the model, it will not able to understand, and it will predict different results, variable results, every time you are running the program. So this step is very important with data preparation, and sometimes it take most of the time. So we will look forward, like when we will do the analysis, we will see how we are preparing the data and what are the necessary steps we need to take. Okay. Okay, so data preparation will include, okay. Yeah, data preparation will include data collection. The first step that first we are downloading the data. Then after downloading, we will first extract the files, and we will see what are the files, and then we will keep them into one different file, because we will keep the raw data different from the processing data. And then we will clean it, transform it. If the rows need to transform into columns, columns need to transform into, or if the data format need to from CSV or the Excel file to the text file, or even XML file, so also we will transform the data. Data reduction will be performed, that is the dimensionality reduction we perform, because we have 25,000, 22,000 genes. We will try to see into one small scale the whole genes in form of a figure, so that we can see like how our samples in the data are behaving, how they are overlapping on each other, how they are grouping together into like each other, like normal samples and the healthy samples and the tumor samples or the disease samples, how they are like looking into one picture, so that if there are some overlapping samples, for example, like samples, healthy samples are overlapping with some of the disease samples, so we will try to remove those samples, because those samples are going to give us misleading results, as we have also discussed this briefly in the last lecture, that overlapping samples we will remove in this preparation step. And then we will split the data into training and testing set, so that we can train the model. Okay, so in data preparation, again, we will do data cleaning and data transformation. So these steps are we will do while doing the analysis. Where data preparation include data outlier detection, because here we can see like some of the samples or some of the, like, these can be visualized in terms of samples also, and some it can also be visualized in terms of genes also, the genes present on in our data. For example, we want only those genes which are like showing the gene expression below 100, so we will remove these three genes. We will try to label these genes, that what is the name of these genes through our program, and then we will remove these genes because these are not like coming under our cutoff category. So outliers are basically the data that which is not under our threshold value or cutoff value that we are going to provide in our analysis. Then again, feature variance, like we will see that what features which are given, like gene expression we have given. So how many genes are expressed in each category. Sometimes in some samples the genes are very less number of genes are expressed. For example, here we can see in in the category 100 to 120, or even yeah, even 0 to 100 category, we can see very less number of genes are expressed. Even they are not visible, and sometimes we can see they are around 10, or maybe 7 8 genes are available there in these samples. So we will try to remove these samples, or we will try to handle these samples very carefully, because very less number of genes are there. So whenever we are using some threshold value, we need to keep this in mind, that okay, these samples, whatever the labels of these samples are there, we will keep in mind that all the genes, for example, very less number of genes are expressed, then we will see that we should not put such a cutoff that no gene is expressed in one sample. So that is not possible anyhow. So we will try to see that what is the variance of the feature, like how the feature are varying in our data. And then in data preparation we have targeted columns, like diseased column, or the healthy sample column, or the treated column. So how many number of samples are there? For example, here, if 1 is the disease sample and 0 is the healthy sample, like where no disease is there, so 0 label is given. So we can see in the diseased column we have more than 500 samples, but in the healthy samples we have only 500 samples. So we need to visualize and see and make a report of all these things, because we need to first understand our data better to make a better performing model. While choosing a model, we need to keep our objective in mind, and then we will go for data analysis. In data analysis, we will choose the model, that which algorithm we are going to use for data analysis. And then again, we will see the features and the parameters. So features are basically parameters itself. We use alternatively these two keywords, where we will see that which features are important. As I give an example, like gene expression is there and then age is there. So for both, the scale of the numbers are different. Expressions are between 1 to 10, depending on the data set that we are taking. And then we have the ages between 0 to no, like if we are talking about cancer, so maybe like from 15 to 90, or 15 to 99. So like that type of data we have in the age. So we will try to some remove some features as well, or adjust some features, maybe normalize the scale of the data. So based on that, then again we will see what is the data variation, like how gene expression is changing. Like if gene expression in one sample is 1, then other sample is either 2 or 3, or either it is if in one sample it is 1, then in the next sample if it is 10, then that is too much variance, right? So this is not a linear data, right? So we need to check the data pattern as well, that how it is behaving exactly in all the samples. So accordingly, we need to first inspect our data very carefully before proceeding to make a model. And then we need to see that which model will be performing, like which algorithm will be performing better, how much time each algorithm, the algorithms that we are selecting, how much time it is taking for to perform the analysis or to build the model, so that because when data is more, so it will take more time, as and some algorithms will take more time, some are very fast, so they do not take more time. So and also then again, choosing model will depend on what is your objective. Like you have to do dimensionality reduction because you have too many number of genes, and you want to visualize that which genes are outliers, which are not good for your data. So you will try to go for unsupervised learning. If you do not want dimensionality reduction, if you have just labeled data having like this is tumor, this is healthy samples, then either it is in numeric form or in the categorical form. So based on that, you will go for supervised learning classification or either regression learning. If the data is categorical or numerical form, you will go for regression. If it is in categorical form, you will go for classification. So based on that also, you will choose the algorithm, that which algorithm you are going to make the model. Again, based on different type of data, as I explained in supervised learning, you will see that continuous data is there as the target variable. Like target variable is like we are going to predict from our machine that whether the sample, this gene is from normal healthy sample or the disease sample. So it is a continuous data like in 1 2 3 4 form, or it is categorical data like healthy or tumor sample, or either it is in number form. If it is in number form, you will go for regression, like we see in the pricing of like house pricing, like what is the rent or something, how much it is going on sale. And in categorical data, if you are going for classification like imaging data or the expression data, if you are going to classify the healthy samples and the disease samples. So based on that, I will share this PPT. Like this is like a whole explanation that we need to totally, or you need to learn these, or even remember these things, because this will be very helpful when you are going to select any algorithm to develop a model. Accordingly, based on your data only, input data, what type of data you have and what is your objective. So based on that, you will go and use the algorithm based on your data only. Okay, so yeah. Okay. So there is one assignment I will be giving you based on this figure that I have, the workflow that is given here. I will be giving you assignment. So please go through these things, like the whatever the content we are providing. Accordingly, you will be learning the things as we are going through the classes. Okay, so again, choosing algorithm will depend on that how your algorithm behaves with different type of data. What is the model relationship between continuous variables? If it is, what is the use case? If there is a continuous data like prices, like sales, like risk assessment for the disease, if you are doing, and then what is the reason of use? Easy to implement. Linear regressions are easy to implement. Some are faster in timing and processing. And some type of, for example, decision trees, so split data in branches on decision making, which is easy to understand the prediction given by the decision tree. So these are the some advantages and the use cases of the algorithms, and there are many more algorithms. So you need to first understand these before diving down in the analysis phase. Next is choosing the ML model. Also depends how the model actually works. So as we have discussed already, that in SVM we do the classification. In decision tree, how it will perform based on the different features. It will see if the feature is going into like which direction, and then based on that, the decisions will be taken in form of leaves and nodes, and make a decision tree where the tree will be, where the final results will be given in form of the last leaf or the last node that is given by the whole tree in top down manner. And this is for random forest, where too many decision trees. Here we can see decision tree 1, decision to true, and n number of decision trees will be made. Whatever, like I explained, right, hyper parameter tuning we will be doing if our model is not working good. So when we are doing random forest analysis, we are making the model. So we need to decide first that how many trees we want, how many decision trees we want in our random forest. So if you are giving 5, then it will only make 5 number of decision trees, and it will give a final votes. Based on the votes, it will give a final decision. But if you are giving 100 in the parameter for the in the argument for the decision trees, so it will make 100 decision trees for same data, and then based on the votes on 100 decision trees, it will make the final decision. Similarly, this is a neural network model where the decisions will be taken based on the layers, and the layers will be decided based on the features, number of features given in your data. So those features will be then deciding the final output from your data. So model selection is important, algorithm selection is important. Then again, once the algorithm is selected, then you need to train the model. In the training model, you have to first split your data into two groups, training and testing, and then that is performed in the data preparation step, right? And then here we will train the model based on our input data that we have selected as the training data. So that this is the step where we will understand better when we are going to do the practical, that how the model is going to be trained. Because when we will do the practical, it will also show that okay, this model is trained, now see what is the prediction it has given. So that we will see there in form of figures also, and in form of codes that you will see, you will understand each module of the this analysis. Then once the model is already made, then we will evaluate the model, that how it is performing based on the test data. Okay, so test data is the same data that we have, not the same data, the data part of the data that we are using as the input data. Some part of the data we have kept it separate to test our model that we are making. So that separate data that we have already excluded from our input while making a model or training a model, we will give now this data as a new data to our model, that whether the model is trying like a model has already learned that what pattern our data is already following. If yes, then the model will give good accuracy, like more than 80% or more than 85%. So there is no standard category that will be the good accuracy, but we usually use it like we consider it like more than 80 and sometimes more than 85 as a good accuracy. So there are different methods for evaluating models based on sometimes we evaluate is at on based on accuracy, sensitivity, and specificity. Then there is holdout and cross validation method where we perform where and then where we use different cross validation, like again and again we give the model that we give 5 cross validation value, then 5 times our model will try to learn from the same data, and then it will give us the make the program or the make the model, so that the learned model is now 5 times learned, so maybe it will work better in the next time. Then again, we need to avoid overfitting and the underfitting while making model and model prediction. So these terms, overfitting and underfitting, we will see while we are doing the analysis. But let me see here if I have added the overfitting, underfitting. So here, where evaluating model, we have the part of our data. So this complete data is our data, which we have downloaded from database and cleaned and prepared this data. Okay, so half part, like some of the parts, 70% or sometimes 75% or even 80% sometimes we use for training the model, and 20 or 25% we use for testing the model. Okay, so when we are splitting the data into testing and training phase, so here is the test data, which is the smaller section, and here is the train data. Then in validation step, like cross validation I mentioned. So in cross validation, what is given here, we are using 5-fold cross validation. Okay, so validation we will give while training our model to improve the performance of our model. So if you are giving 5-fold cross validation, it means 5 times the data will be trained on the same data that we are giving, but every time it will choose different test set and different training set. from the same data, it will take different set. But if you are telling the program that only take 20% of my data as test set and remaining 80% as training set, so every time it will take 80% as training set. Maybe it is from first half or the last half, or from the combination of first few columns and the last few columns, and then 5 times it will give different type of data, but the same data but different part of the data, and then it will train the model, so that model will learn better because it is now providing different set of groups from our data. Okay, so this is fivefold cross validation, which will help us to improve the performance of the model. Again, parameter tuning is for where parameter tuning is again for, I am, as I mentioned, that in random forest we will try, like we are the making the model, so we will try like how many decision trees will be there in our random forest, and then again how many folds we are going to give for cross validation. So that is based on us, and to just to improve the performance of our model, so that is done for the parameter tuning. Just to improve the and improve the performance of our model, we will do parameter tuning and try to modify the parameters, so that the performance or the accuracy will be giving better every time when we are training the data. And there are different approaches for hyperparameter tuning, where manual search, random search, and grid-based search. This we will discuss while doing the analysis, that which type of search we are going to use in our analysis, and you can also explore these keywords. Again, parameter tuning, you can see here. So underfitting and overfitting, I was explaining, right? So here we can see the training points are in blue color and test points are green color. So when your model is trained, like sometimes when you have very less number of data, your model is giving accuracy like 90% or 95%. In that case, it means your model is overfit, or it is showing overfitting, because it is trying to align and giving right result for each data or each sample that you have in your data set. So this is an overfitting of a model, and this is not a good model, because when you will use different data or the new data, it will not perform good, because in that case maybe the data points are at different positions. And then here in not overfitting, here this is good example where your data is just showing a non-linear linear type, but non-linear expression or the pattern, where it is try to cover most of the data, or even it is passing nearby each data. Because here in overfitting, you can see in the first figure, the pattern is going two up, like highest point is here, where if you are evaluating or calculating the distance of green point, like green test point here, it is too far, right? So this is not a good model where overfitting is shown. Okay, so we try to always avoid overfitting by regularization of the model. So that we will also see what is regularization. So L1 type regularization, L2 type regularization, so that we will see in the while analysis. Okay, and good model is here, where the test points and the training points are nearby, and the pattern is learned going through between them, not too far, not too close, that totally overlapping on it, and not too far, totally going away from it. Then predictions refers to the output of algorithm after it has been trained on the historical data. So data that we have already provided, so based on that, whatever the prediction the machine or the model is making, that we have made the model, that is called prediction. So based on the prediction only, because even at the end, if the prediction is made and the prediction is not right, like this example we saw in the last class, where the label data is there and we provided the label that 6 sides will be hexagon and triangle and square of the 4 side, then the model is learned. Okay, now we are giving a new data where the label is not provided that this is square or triangle, but the program, that the model that we have developed here in the second step, so it will try to predict based on the pattern that it has already learned. The prediction will be made based on that, and now the program is predicting that this four-sided shape is the square and the three-sided shape is the triangle. It means now our model is learning good. It has good accuracy, like it is showing here 100%, but when we will do like the analysis and we will get the results, it will not show totally 100%, but like 0.8% or 9%. In percentage, it will give 80%, 90% accuracy. Okay, so but here we can see now it has correctly labeled our figures or the shapes that we have given. So this is called prediction. Once the model has already learned, now it is the test time. Okay, so we need to test the model that whether it is predicting right, whether we are giving the samples and it is predicting right or not, whether it has learned enough or not. Like as you have exams, right? After a whole year of the study, you have the final exams, so there the teacher will assess whether you have learned the whole year or not. So that's it. It is not a magic that what is going on behind the machine, I don't know, it is just a magic happening, this is out of my world or something. It is not like that. This is a machine, like it is just the mathematical programs going behind it, and every like SVM, support vector machine, random forest, whatever is there. So for every algorithm, there is a mathematical equation, mathematical programs going behind them, and they are just calculating and learning from your data. They are just making relations between your features and the labels, and that's it. Then the prediction will be made based on the features, and then the square and triangle will be predicted correctly based on the patterns that is learned from the data. Again, the applications of the machine learning we have already discussed, and there are many applications apart from just disease categorization and image categorization there, because we know like in every field we have machine learning, so we can do many things, but our program is about gene expression analysis. So let's just explore gene expression analysis itself from the next class onwards. Yeah, so that's it. Let's open the let's unmute yourself and like show your queries, or just tell your queries, whatever you have. Let me also check in the chat box, and we will see in the next class. Okay, so I have one query from Vedad. Vedad, is feature equivalent to variable? Yeah, like it depends on the data that you have. If you are calling it, calling the like column names a variable, the header is there, which is defining that what type of data you have in that column. For example, as I have shown that there is a temperature in one column, then there is a humidity numbers on another column. So based on that, whatever data that we have in our data set, which is helpful in uh, evaluating or predicting your final results, that will be a feature. Okay, and sometimes even we call every all the columns in our data or the information that is given as a feature, but sometimes some features are not relevant, not good, so that we try to split it out from our data. But whatever data that we have, we can call or refer it as data. So if you are calling that as a variable, then yeah, that is feature. And in terms of gene expression, we usually call genes as a feature in our data. Okay, can you repeat a parameter step for machine learning? Parameter. Okay, maybe this we can like you can just like elaborate your question, because I'm not understanding this is parameter tuning or what exactly. So you can just post it again or ask it by opening your mic, or just drop down in your later on. If you want to ask, you can drop in your discussion forum. And the rest of the things are, I think, about programming languages. Okay. can you say the use of CERAT versus ScanPy? Many people don't trust ScanPy for biological data analysis. Okay, so here you must be talking about Divakar Ravi. Okay, I'm reading your question. CERAT and ScanPy are used for single cell RNA-seq data analysis. And yeah, we can both the tools we can use, but most very frequently CERAT is being used for single cell RNA-seq analysis. Okay, yeah, so difference, like there are very critical difference or very less like negligible difference between them, or maybe more in depth need to go through. So maybe you can just post this query in the discussion forum. I will explain you there in the detailed form, because here we need to be concise, right? And relevant to our today we have machine learning, so let's just be strict to it. Okay, is fold change of gene expression called label? Yeah, if we are using the analyzed data, for example, once we what I was talking whole time about was the raw data. Like we have the gene expression and the labels as the healthy samples and the disease samples. Okay. So when we have already processed the data and we have the gene expression, we have the gene name in the column, we have the log fold change values, we have the p values. So in the process data, we have we use sometimes log fold change and p value, adjusted p value as the labels. Not labels actually, because labels are the output, so we use them as a features. Okay, hope that is clear. If not clear, please drop down this query in the discussion forum. Okay, the next question I think is from Murali Krishna. Like how exactly we train the model? For example, we use identification, any cells by morphologies. Okay, so it depends on the objective of your analysis actually, because here we are talking about gene expression based model training, or the training the data for model preparation. So based on that, we will use gene expression data. But if you have the expression data based on cell, here, like in single cell RNA-seq data, we have cell based expressions in our data, so that also we can use for model training. Okay, so parameter tuning, maybe you are asking about it. I'm not sure if you are asking what is parameter tuning. So like I have explained, but briefly I can tell that parameter tuning is used to optimize our machine learning model. For example, the model that we have developed or the designed using the default parameters that is given, but the accuracy is not good. So what we do is we try to improve the model performance by giving more number. For example, in random forest, we have the possibility to give the number of trees that we want to use for our data modeling. So for that, we can increase number of trees in our model. And then again, okay, and again, for other algorithms also, for each algorithm there are different arguments or different parameters that we can modify. Okay, so that is parameter tuning. And also now, okay, then, so can we have multiple labels for same data? Does it need to be trained separately for each label? No, actually, usually we need to have two models when we are doing classification for our data. So two labels is okay. Two labels is as either it is the disease sample or the healthy sample, or maybe sometime it is disease sample, healthy samples, and treated samples. So we can have multiple labels, like not only two labels, but we can have more than two labels as well. And we do not need to train separately, but we can also train separately. That totally depend on the whoever is doing the program and what is the objective. Okay, so Kaviraj, My question is, how efficient will the pattern identification of machine learning algorithm be when compared to traditional differential? Okay, if it is effective, how it is? Does it contain any deviation from traditional DE analysis? Okay, so this is a long question, and I think it covers the whole like objective of our course. You can, but still I will answer your question. But please drop down this query, or maybe at Nyberman we will drop down your query in a discussion forum. It's better you will drop down your query because it is like important for you. So drop down your query there. I will explain it there. Yes, it is efficient. So briefly, let me explain because I don't want to keep it like incomplete. Okay, incomplete. So yes, it is efficient. Machine learning algorithm will be efficient in pattern understanding for our gene expression based data, and it is different. It is not different. We are not trying to differentiate between traditional bioinformatics analysis and machine learning. We are trying to with this course we are trying to integrate both the results. From traditional analysis we will find the genes, and then from machine learning algorithms we will trying to find the important genes, and then from both the analysis we will identify common genes to perform further analysis, so that we will have one very precise results and very important genes in our data, because those genes are confirmed from our traditional analysis, bioinformatics gene differential expression analysis, and also from machine learning analysis. So those are the confirmed genes and important genes, because we have achieved them differently from two different approaches and the same genes. So common genes we are going to achieve with this work study or the course. Okay, what is the minimum number of samples required in each label for model prediction? Okay, so okay, Deepti. So you are asking for the minimum number of sample. It is not like specific that what is the minimum number of samples, but the more number of samples, better your prediction will be, better your model will learn from your data, because it will have more data to learn, more patterns to understand exactly what is going on with your data. So like hopefully, but when we do bioinformatics analysis we try to have at least eight samples in one category. For example, 8 healthy samples and 8 disease samples. And like similarly we can use in machine learning also, we can go onwards like more than 8 or more than 10, more than 12. So we will try to, but for machine learning usually that again also depends on which algorithm you are going to select, because some of the algorithms work very well on the less data, but some algorithms need more data because there is complicated learning algorithms, learning mathematical function for those algorithms. So we need more data. So again, that is also one of the major steps that we are going to see while model selection or the algorithm selection for developing the model. Okay, Imran, so will you please explain the basic principles of different models used in machine learning upcoming PPT? Yes, sure. I will explain it. Don't worry. And even if anything is missed, you can just remind me there itself. I will definitely explain. I have noted your question. Don't worry about anything that is going to be missed. Everything will be explained. You just like anyone, whoever is not even asking queries or whoever has queries, just drop down your any sort of query even after the class also. Any sort of query you have, you can just drop down in your discussion forum. I will be there and I will answer you. Okay, I think that's all. So everyone, whoever have questions apart from this also, like not apart from the course, but within the range of our course, so whatever we are going to cover, you have already have the syllabus. So just drop your queries in the discussion forum. See you in the next class. And
Well,
don't forget, sorry, Bhavani, don't discuss
obviously,
to don't discuss to like share your feedback, because that will help to improvise in the next class. Okay, so that will be better. Yeah. Yeah. Good evening, everyone. Have a good day.
yeah. Thank you, Gazala, for the most informative session on machine learning. I guess
Thank you
this
so
1 hour
much.
session might give an overview of what the whole machine learning is. Thank you so
Yeah,
much.
thank you so much. My pleasure.
Yeah. Dear participants, as Dr. Gazara requested, kindly fill out the feedback form, which will help us to give more better sessions in the upcoming days. So I request everyone to fill out the feedback form and give your positive as well as the constructive feedbacks. Thank you all for joining us. Let's meet tomorrow by the same time. I request everyone to join us on time so that you won't miss any of the initial sessions. Thank you all.